Okay, for the problems number 1 on 8.2, they were told that frequency varies inversely as wavelength. So let's call F frequency, I guess. If it varies inversely, we'll have a constant of variation. And then inversely means that the wavelength will go on the bottom. Now, there are probably better letters to use here. I'm just trying to make sure we can keep up with where we need to put stuff. So what they want us to do, they give us one piece of information that we can plug in, and then they ask us to find what frequency has a signal of 400 meters. So we're actually trying to solve for an F at the end. All right, if you look up at the information they give us, I'll kind of use green to kind of underline it. 12 kilohertz is the frequency, and 250 meters is the wavelength. So let's plug in 1200 kilohertz. And we've got some constant K on top, and then on the bottom we're going to plug in the W, the wavelength, which is 250 meters. Now if I want to solve this, I can turn this into a proportion by putting 1200 over 1 and cross multiplying. 1 times K is K, and then 1200 times 250, let's see what that is 300,000. Okay, so K is 300,000. Now remember, when we find K, then we then go say, okay, that helps me write the real equation. It's not just K over W, it's 300,000 over W. So now if I want to find a frequency with the signal of 400 meters, all I've got to do is plug this 400 in for the wavelength here. Okay, so that's going to be F equal 300,000 divided by 400, and so the frequency would be 750, and that's measured in kilohertz. Okay, so again, this is not any different than the problems above. All right, I tried to color code this. The black will help us, the black writing will help us write the equation. It says the heat loss, let's call it H for heat loss, okay? So heat loss varies jointly, so right across on the other side, we're going to put the area, and it says it varies jointly as the area of the window and the difference inside and outside temperature. So let's call the area A there, and we'll call the difference D. I'll call capital D, okay? Okay, so that looks kind of weird, but we get in the green, we get information we can plug into that so we can find the K and write our equation, okay? So the heat loss is 720 BTUs. I have no idea what that means. But we have a K. The area is 3, and the difference is 15. Okay, so that's going to be what, 45K? 720 equals to 45K. So if you divide both sides by 45, let's see what that's going to be. 720 divided by 45 is 16. All right, so what's our equation really? Well, K is really 16, so we can say that's just H equals 16 times the area times the difference in temperature. You might have made different variables for yours, that's fine. All right, so what is the heat loss? We're solving for H. The window, so we put the 16. The area of the window is 4.5 meters squared, so we'll put that. And the temperature difference is 12. So really all we have to do is multiply out 16 times 4.5 times 12. And we get 864. H equal 864, and the unit on that is going to be BTU. And that's it.